What's going on, 7th grade? Welcome to our study guide video for Unit 4, percentage change and some proportions. Let's get it. Alright, let's get started on our first problem of our study guide. Here we have that a soccer field is 360 feet long. Han measures the length of the field using a 30-foot long measuring tape and gets a measurement of 358 and 92 hundredths feet. And so step one, in order to solve this problem, says we need to find the error from the actual measurement and your measurement. And so what we're trying to do here is to find the percent change. And so we're trying to find the percent change. And so in order to find the percent change, or in this case actually not percent change, but percent error, is we need to find out what our actual error is going to be. And so for instance, here is the true measurement. This is the actual measurement, right? And our measurement is going to be our new measurement. And so to find the error, we need to find out how bad or how big or how small our mistake was. We need to figure out what is the difference. So we find the difference. And so we do 360 minus 358 and 92 hundredths. And we can do that out, or we can put it in a calculator. When you put it in a calculator, you end up getting that your error is going to be 1 and 8 hundredths. And so what we write here is we underestimated or undermeasured by 1 and 8 hundredths feet. All right, well, let's move on to the next part. So step one is to find your error, and step two is find the percentage that your error is from the actual measurement. And so our actual is equal to 360 feet, and then our error that we just found was 1 and 8 hundredths. And so what we need to do in order to solve this problem is our percent error is equal to our error over our actual. And so we end up getting our percent error is just equal to 1 and 8 hundredths over 360. And so again, you put that in your calculator. And so we have our calculator here. Let me actually get my calculator out. Here we go. And so we have 1 and 8 hundredths divided by 360. And so we end up getting 0 and 3 thousandths. And so what we remember from class, in order to get from a decimal to a percent, you multiply by 100, and that just moves the decimal place over 2 times, and we end up getting 0 and 3%. And so we would say our percent error is 0 and 3%. And so now here's how to explain your reasoning, show your work, through your work, I should say. And now not only that is we also want to be able to write out our work. So what we would say here is we would say the percent error or measurement error, the percent error is 0 and 3%, right? We state our answer. I know this because, and then what I do is I explain my work, right? So I start here. I say, I know this because the actual measurement is 360 feet, and they under measured by 1 and 800ths feet, right? So I got that part here, right? We got an error of 1 and 800ths feet, right? By doing 360 minus how much we erred, right? We obviously undermeasured. And so that's what I put here. I know this because the actual measurement is 360 feet and they undermeasured by 1 and 800ths feet. I then understood that 1 and 800ths is 0.3% of 360. And so this is one way to explain your answer. You could also just write out your math here, but we can also just use our words. Let's move on to the next one. And so now we're moving on to our next problem. The price of a shirt is $18.50, but you have a coupon that lowers the price by 20%. What is the price of the shirt after using the coupon? Well, a coupon lowers the price. So first off, we know that this is a percent decrease. And so a tape diagram to represent this situation is I could have the original cost, and then we get the new cost, also known as the discounted cost, here. And so we have our original cost, and what we remember from class is that our original amount always represents 100%. And in this case, 100% of the original cost is just $18.50. And then our new amount, we don't necessarily know what that is yet, but we know that 100% is going to be $18.50. But, right, we decrease by 20%, so we minus 20%, and then that ends up just giving us our 80% here. And so we know that we're trying to get rid of the 20%, and so we're trying to figure out how much our new shirt's going to cost. So step one is to find out the percent of the whole that it decreased. For instance, we decreased by 20%, so what we should do is find 20% of $18.50. Now there's two ways. I like to make it into a fraction, but you could just do, right, 0 and 200ths or 0 and 2/10. I'm sorry, 0 and 20 hundredths or 0 and 2/10 times $18.50. And you end up getting a discount, right? So you would do 20 hundredths times $18.50. And you end up getting $3.70. And so what we end up getting is a discount, right? Discount of $3.70. And so since this is a percent decrease, we want to subtract that amount from the original amount because we're not spending $3.70. What we're doing is we're getting $3.70 off $18.50. And so what we do is we do $18.50 minus $3.70. And so when we do that, $18.50 minus $3.70, we end up getting $14.80. And so an equation to represent this situation, well, we have two equations. First, we have our new amount is equal to 100% of our original amount minus, because this is a percent decrease, 20% of our original amount. Or we could look back here, right? We know that our new amount is 80% of our original amount. So it could have been y is equal to 80% of our original amount. And so to explain your reasoning here, we would say the discounted shirt costs $14.80. I know this because 20% of $18.50 is $3.70. I then subtracted $18.50 by $3.70 to get the discounted cost of $14.80. So we say our answer, and then I know this because our reasoning. And so if you think about it, it's like class. We have our claim, and then we have our evidence. Or in this case, there's not really, yeah, all right. I tried. But yeah, and so good job. And let's move on to our next one. All right, so let's talk about this problem here. So in this problem, we want to calculate how fast each person goes and then compare who's faster. So here we have Lynn, here we have Noah. And so part A says, how fast did Lynn travel if she ran 2 3/4 miles in 2/5 hours? And so this is a throwback to early on in this unit and last unit where we found constant of proportionality, which was K. And what we understand is our constant of proportionality is a constant rate, but it's a ratio between our dependent variable and our independent variable. So in this case, right, what we always know is time, for the most part, will always be our independent variable. And so our independent variable is 2/5 hours, which means our dependent variable is the 2 3/4 miles. And so what we need to do here is understand that how far we go depends on how long we travel. And so what we understand is our constant of proportionality is just going to be our dependent variable over our independent variable. And so this throws us back to earlier on. But first off, right, a variable for miles could be m, and then a variable for hours could be h. So we could represent this as m over h. And so to get our constant proportionality, we have our dividend divided by our divisor. And so we can set this up like so, where it's 2 3/4 divided by 2/5. And so before we can multiply or divide two fractions, we need to make them from mixed numbers to improper fractions. And so we do 4 times 2, which is 8, and then add that to 3. 8 plus 3 is 11. So this becomes 11 over 4 divided by 2/5. And so what we know is when we divide by a fraction, we want to multiply by the reciprocal. And so we want to keep our dividend, change from division to multiplication, and then take the reciprocal of 2/5. So we end up getting 11 over 4 times the reciprocal of 2/5, which is 5 over 2, which is why we want to say that we are going to multiply, right? We're multiplying by the reciprocal. And so 11 times 5 is 55. 4 times 2 is 8. And so what we understand is that 8 goes into 55. Six times, and we end up getting 6 7/8. So what we end up getting is that Lynn traveled 6 7/8 miles per hour. And so what we want to do is now get Noah's time. So Noah's the same, right? We have miles over hours. But here it says he went 8 2/3 miles in 1 1/3 hours. And so it's the same concept, right? We want to find K. And so it's a ratio between our dependent variable and our independent variable. So we do 8 and 2/3 divided by 1 and 1/3. And so I can set this up as a division sentence of 8 and 2/3 divided by 1 and 1/3. First step is to go from mixed number to an improper fraction. So I can do around the world. 3 times 8 is 24. And I add that to 2. 24 plus 2 is 26. So this is 26 over 3. So all I did is convert from a mixed number to an improper fraction. Divided by, right? 3 times 1 is 3. Then I can add that to 1. 3 plus 1 is 4. So this is 4/3. And just like before, I want to multiply by the reciprocal. So I keep my dividend. So I keep 26 over 3. I change from division to multiplication. And then I take the reciprocal of 4 over 3, which is just 3 over 4. And now I can multiply across. So what we end up getting, 26, what we'll do, 3 times 4 is 12. 26 times 3. Well, that one's a little harder, so maybe I do that on the side. 3 times 6 is 18. Regroup our 1. 3 times 2 is 6. Plus 7. Plus 1 is 7. So that's 78. And what we understand is that 12 goes into 78 6 times. And so, right, so maybe I do it like this. 12 goes into 78 6 times. 6 times 12 is 72. 78 minus 72 is 6. So this is 6 and 6/12, which reduces down to 6 and 1/2. So this is 6 and 1/2 miles per hour. And so when we compare these, who's faster? Well, Lynn traveled closer to 7 miles per hour than Noah. So because Lynn was traveling more miles per hour, we know Lynn is faster. So we would say Lynn is faster than Noah. Right? We don't stop there though. I know this because Lynn traveled 6 7/8 miles per hour, which is faster than Noah's 6 1/2 miles per hour. And so that's again how we would have gotten this question here. And so just a reminder, I know it was a lot of math. At the end of the day, if you understand that your constant proportionality is a ratio between your dependent variable and independent variable, and you're strong at dividing mixed numbers, then comparing these rates becomes a little bit more manageable. All right, so here is another example of percent increase. So here's finding the original amount. Finding the new amount. And then the next one is finding the original amount. So let's get started. A car dealership pays a wholesale price of $12,000 to purchase a vehicle. The dealership wants to make 32% profit. So part A, how much will the dealership need to mark up their price? What will be the price after the markup if they want to make 32%? So here we have our wholesale price. And so wholesale just means that the dealership is buying them in bulk. And so they get it for a cheaper price than what they're selling because they want to make money. And so here our original amount is always 100%. And what we understand is the car costs $12,000. And so when they sell it to you, that's called retail. And so we don't know how much they're selling it for, but what we do know is that 100% is their original cost, which is the $12,000, plus the 32% that they want to sell for, which in all means that what they're selling for is 132% of their original amount. And so how much would they need to mark up? Well, here we can just do 12,000 times our markup of 32%. And so that just becomes 12,000 times 0 and 32 hundredths. And so 12,000 times 0 and 32 hundredths just gives us 3,840. And so what we end up getting is that we marked up by 3,840. And so we're marking up, meaning it's a percent increase. And so we just want to add that on. And so we do 12,000 plus 3,840. And what we end up getting is that the retail price is just 15,840. And so a reasoning would be they sold the car for 15,840. Right? We don't stop there. I know this because they marked the car up 3,840. And again, I got that number from our work here that we did. And I added that to 12,000 to get 15,840. And so now that was part A, and now we can go to part B. That's just slightly a little different. And so here we have the car dealership across the street marked up their car by 28% and sold it for 16,000. How much did they pay wholesale? And so in our prior problem, we understood that wholesale was our original amount. And so since we're looking for wholesale, that means we're looking for our original amount. And so here, right, we have wholesale, which we don't know how much they spent, but what we do know is that our original amount is always 100%. And so we start with our wholesale, and then we go to retail. And the retail cost we know is 16,000. So our original amount was 100%. And then we marked up the car by 28%, so plus 28%, which means that the cost for retail was 128% of the original amount, also known as 16,000. And so step one, find the percent the new amount is of our original amount. Well, if we increase by 28%, that's 100% plus 28%, so it's 128%. And then finally, step two, divide the new amount by the percent it is of the original amount. And so this means our original amount is equal to our new amount of 16,000 over our percent of 128%. And so what we know is to get from percent to decimal, we divide by 100. So in our calculator, we can put 16,000 divided by 1 and 28 hundredths, which when we do that, 16,000 divided by 1 and 28 hundredths, we get 12,500. So that means 16,000 divided by 1 and 28 hundredths is 12,500. So we would say the dealership bought their car for 12,500. I know this because I divided 16,000 by 128% to get 12,500. And so now we have one more problem and we're done with our study guide. All right, so by the time we get to this problem, hopefully we're a pro. So here we have a PS5 is on sale for 15% off. So we know that this is going to be a percent discount a percent decrease because it's on sale. The regular price is $425. The sales tax is also 6%. What is the price of the PS5 after the sale with the discount and the sales tax? And so here we want to find the price with the discount. And so our discount's 15% off. And so what we want to do is figure out how much we're going to spend. So if we remember from our prior problems, we want to do our original amount times our discount, which is 15%. And so this becomes 425 times 0 and 15 hundredths. Or we could say 15 over 100 and do it that way. And so 425 times 15 hundredths is equal to $63.75. But this is a percent decrease. So what we want to know is we want to subtract that from here. So x is equal to 425 minus $63.75. And we end up getting that the price after the discount, so the PS5 costs $425, subtract the discount, we end up getting $361.25. But now, right, we're buying it for that, and so now we need to do the sales tax. And so our sales tax is 6%. So we started off with a decrease, but a sales tax means you're going to spend more. So now this is going to go to a percent increase. So we take this number up here, and now we do x is equal to $361.25 times 6%. And so here's method 1 of solving this. I'm going to show you method 2. I like method 2 better. So this is x is equal to $361.25 times 6%. Percent means per 100. So this becomes 6 over 100. And so now I can place our original price over 1. So $361.25 times 6 is going to give you x is equal to $2,167.50 over 1 times 100, which is 100. And then I can just divide this by 100 to get that the discount was $21.60. I can round this to 68, right? Because the 5 is bigger than 4, so you want to make the 7 and 8. And so I know that our sales tax is $21.68, but that's an increase. So I do x is equal to $361.25 plus $21.68. So this is our sales tax, by the way. And so I do $361.25 plus $21.68 to end up getting the total cost of the PS5 to be $382.93. But again, we're not done there. We now need to explain our reasoning. So we would say the price of the PS5 after the discount and sales tax is $382.93. Again, we don't stop there. I know this because 15% of 425 is $63.75, and 425 minus $63.75 equals $361.25. So that was, right, this part here is here, right? 15% of 425, 15% of 425 is $63.75, and 425 minus $63.75 is the price after the discount. And so what did we do after that? We added on our sales tax. I then calculated our sales tax of 6% to get $361.25 times 6%, which is $21.68. As a result, the final price was $361.25 plus $21.68 to get $382.93. And bam. I know that's a lot of reasoning with words, but I'm telling you, if we're able to get our work on the scrap paper and then on MCAS explain how we got our answer, we'll get all the credit, if not some credit. And so we start off with the first part here. I then calculated our sales tax, bam, of 6% to get $361.25 times 6%, which we did here, to get $21.68. As a result, the final price was $361.25 plus $21.68, which is our final answer. So good luck on our test. I know we did a lot of work here, but you guys are ready and you guys have done an amazing job this unit.